The second part of these notes is going to be converting between polar and rectangular coordinates. And so essentially what that comes down to is if I put a regular coordinate plane over a polar coordinate plane, these points are going to match up. So r comma theta being a point is equivalent to a specific xy coordinate. And how are those things related? Well, I can draw in this triangle, kind of like what we've been doing with the unit circle. R is that distance, that hypotenuse of the triangle, and x and y are the two sides, and then theta is that angle in the center. So I know some things. I know, for instance, that x is equal to r times cosine of theta. I know that y is equal to r times sine of theta. So we'll start there, going from polar to rectangular coordinates. If they give me, they say find the rectangular coordinates of the points with the following polar coordinates, they give me r and theta. So if I want to find the rectangular coordinates x and y, well, to find x, I can plug in r times cosine of theta. So 2 times cosine of 3 pi over 2. And I want to make sure some of these are going to come out to be whole numbers when you type them on your calculator, and that's fine. But I think they're going to want fractions with roots in them potentially, as opposed to using your calculator and getting decimals. So I would just say use your calculator with caution. I would rather you use your unit circle. So the cosine of 3 pi over 2, cosine is the x coordinate. The x coordinate of 3 pi over 2 is 0. So I'm taking 2 times 0, and I get 0. So the x coordinate is 0, which is what your calculator would have given you. No problem. And then if I want to find the y coordinate, I'm going to take the formula up above here that y equals r times sine of theta. So 2 times sine of 3 pi over 2. So I'm taking the sine of 3 pi over 2, which is the y coordinate at 3 pi over 2, which is a -1. So 2 times -1 is -2. So the polar coordinates, or the rectangular coordinates that are representative of this, is the point 0, -2. So let's look at 2, 3 pi over 2 on our polar coordinate system. So if I was plotting 2, 3 pi over 2, they would say go out to the second ring and then rotate 3 pi over 2 radians. So it would be this point right here. And if I imagine this as just being a normal xy coordinate plane, the point 0, -2 is also right there. So that just means they're the same point, they're representing the same place. So if you want to pause the video and try part B, you can do that. And so when I take the x coordinate, I'm taking r, which is -8, times the cosine of pi over 3, which is -8 times the cosine of pi over 3 is the x coordinate, which is 1/2. So -8 times 1/2 is -4 for the x coordinate, is -4. And then for the y coordinate, I'm taking -8 times the sine of pi over 3. And the sine of pi over 3 on my unit circle is √3 over 2. So -8 times √3 over 2, or let me write it out here, -8 times √3 over 2. This is the same thing as being -8 over 1. So you can multiply across the top -8 √3 over 2, or you can recognize at any point that 8 and 2 are going to cancel to be 4 and 1. So we would get -4 √3. So the coordinates for the rectangular coordinates are -4, -4 √3. And I am about certain that my math lab would rather you write -4 √3 as opposed to, well, let me put myself in radian mode. And I would take -8 times sine of pi over 3. And it would give me this decimal. And I almost guarantee that they want you to write -4 √3 as opposed to the decimal. So just keep that in mind with your calculator. If I did -8 times cosine of pi over 3, they would give me Oops, I got an extra answer in there. -8 times cosine of pi over 3. It will tell me -4, those exact answers, but just be careful with the roots. So that's why I recommend you use your unit circle.